Hi, welcome back. In this section, we're going to talk about the M in the CAMS model, measurement. We'll take a look at measurement concepts, so we'll have a framework for understanding the rest of the things that we're going to do in this section. We'll take a tour of Graphite, one of the most popular open source metrics and monitoring tools available today. We'll talk about getting our data into Graphite and see how to do that, and then expand upon that as we talk about monitoring agent examples, which will now allow us to send lots more data into Graphite. And finally, we'll take a look at actionable data. In this video, we're going to discuss measurement concepts. We'll talk about the different types of metrics that you can send into your metric system, in my opinion. We'll talk about the push versus pull debate, which has been raging in the monitoring community for years and years and years. And finally, we'll talk about dashboard pros and cons. So there are a number of different kinds of metrics that you can send into your metric system. One of the most important, but certainly not the most important, are system metrics. The example on your screen shows CPU metrics, and it can be other things like that. It can be memory, it can be disk, it can be network, it could be your load balancer, how many requests is it serving a second, what are its response times. But system metrics tell us about the behavior of the underlying system. If I release a new piece of software and my CPU utilization goes way up, is that okay? How about response time? It really depends on what we define as acceptable for our system. But our system metrics give us an understanding of some of the underlying behavior of our entire system. Another kind of metric we can collect are application metrics. In the example on your screen, it's number of items in Memcached, but it can be things like number of items in a queue or a cache. It can be timing metrics, like how long does it take for a call to a REST service to come back. And in order to get application metrics, we either collect them from the application that we're using, or we need to instrument the application code. And these application metrics tell us about the nature of the application itself. What is the application doing internally? It's also really useful if you want to find things like bottlenecks or bugs in our application, because this gives us a lot of visibility into the internal workings of the application. And the third kind of metric are KPIs, or key performance indicators. The example here is the number of calls into our customer service center. If we do a release and the number of calls goes up, we want to know about that. One of the great things about KPIs or business metrics like this is it gives us a holistic view of the system. Like we talked about before in the first way, we have to have a systems thinking approach to what we're doing. And in this case, these business metrics give us a systems thinking approach. We're looking at how are things affecting our customers. If we looked at one small part of our system, say our system metrics, and we didn't notice that we're having a negative effect on our customers, then we're not having a systems view of what's happening. So the business metrics are very important, and we can track them. So that's great, but how do we get things into our system? Well, there's two schools of thought. One is the push model. In the push model, the agents or the applications or whatever we're monitoring push their metrics into the metric system. And this plays really well into dynamic infrastructure, service-oriented architectures, things that would use, say, service discovery, where something would register in Zookeeper, and we would use that to find like Memcache or our metric server or things like that, because we don't actually have to go out and find these things, because these things will automatically go and push their metrics into the central metric server. And this is great for short-lived infrastructure. Right now we have new things on the horizon in DevOps, like serverless and AWS Lambda and Docker, and all of those things can push their metrics into a metric system. One of the other advantages is that our application, or the agent that speaks to our application, only needs to understand the metrics protocol. We don't actually have to have our metric system understanding how to speak SNMP and SMTP and any other kind of protocol that would be out there that we want to collect metrics from. Instead, everything speaks this one protocol of the metric system, and they push their metrics into there, which means that we can distribute our work to the edges. We don't have to have a massive metric server which goes out and does polling in addition to having metrics on storage, on disk, and rendering them and things like that. Another advantage is that if I've collected all the metrics that I want to push into my system, my metric system, and I want to have redundancy or resiliency, once I've collected those metrics, sending one packet to one place and another packet to another place is not a big deal because I've already done all the hard work. So it allows me to push to multiple locations at once. The other side of the coin is a little different. With a pull model, our metric system goes out and collects metrics from all the different things that it wants to monitor. So the classic example of this would be SNMP, which is on our routers, our switches, mostly of our network gear. Even our host can actually speak SNMP. There's some hybrids. There's things like JMX Trans, which does JMX bean collection. It has a poller, which goes and polls JMX, but it even has a graphite output, which will allow it to push metrics in. There's a new piece of software on the metric scene called Prometheus that's decided to go with an all-pull model. If you remember Nagios from many years, where lots of people have been using it, it is mostly a pull model with some push allowed, and Nagios calls those passive alerts. And one of the great things about Nagios was that it also does alerting, and alerting is really important, and we're going to talk about that a little bit later. I think that the pull model is probably best for longer-lived infrastructure, like if I have a data center where things aren't going to move around a lot. Because when I have something like Lambda or Docker, where my application can live for milliseconds or maybe even a few seconds, how am I going to pull that? Pulling information out of those short-lived pieces of infrastructure is a pretty difficult problem. If you want to know more about some of the pieces of software we just mentioned, you can find out about them here with the resources on the screen. And we're going to talk about dashboards. Dashboards are great. They can tell us all kinds of things. Like you can see here on your screen, they can tell us about disk, they can tell us about CPU, they can tell us about memory. And there's some great things about dashboards, and there's some not so great things about dashboards. One of the great things about them is we get our information at a glance. Just by looking at that last screen, you can see all kinds of things about the system just with a single look. When we're troubleshooting an application, I can pull up a dashboard that's built specifically for that application. Maybe it's my web server, or maybe it's my application server, and I can see a number of different metrics about that application. I can see response times, I can see number of requests, I can see all kinds of things, and that really allows me to understand the nature of my application. When we're doing things like that, you should always remember to mark your deploys. So if you see that line on the graph and something changes, you'll know, or at least have an inkling, as to why that thing changed. And dashboards are great for troubleshooting, but they're also good for exploratory testing. If I'm developing a new application and I'm watching the dashboard as I develop, then I'm actually going to get to know what's normal for that application. And having that idea of acclimation to normal is really important, because if I don't know what my baseline is, how am I going to know what's an anomaly? We used to have an information radiator at a place I worked, and it would just sit in the ops area. And people would come into the ops area to talk about this thing or that thing that they wanted to get done. And sometimes they would walk over to the dashboard and they would say, "Hey, what's that?" And we'd look at it and we'd say, "Yeah, what is that?" And sometimes it would be something that we should investigate. Maybe it was a problem. But by having that dashboard up at all times, we were able to acclimate to what normal is for that application. And getting used to normal is really important. And another great thing about dashboards is it allows us to highlight really important metrics, things that we want other people to know what's normal. This is the part of sharing that we'll talk about in the S in the CAMS model. If you go to Etsy in New York, one of the online marketplaces, they're famous for having dashboards when you first walk in, and they show lots of metrics that are really important to the company. And when you walk into Etsy, you'll get an idea right away of what are things that the company considers to be important. But there are some cons to dashboards. For one, who wants to stare at a dashboard all day and night? If I want to know about my CPU utilization, I don't want to sit there and look at a dashboard all day. Can I never go to sleep? Can I never take a vacation? That's a problem. And also, it doesn't scale. If I want to monitor 10 metrics, that's one thing. But what if I want to monitor hundreds of metrics? At Librato, we monitor hundreds of thousands of metrics. I can't have dashboards all over the place that have every single metric that I would ever want to look at, and I would never be able to look at them if I did. So what's the solution? We need to monitor our metrics. We want to have a system that can actually look at those and make decisions. Before we do that, though, we're going to need a metric system that can ingest our data and store it. And we're going to talk about that in the next video. In the next video, we're going to take a tour of Graphite, one of the most popular metric systems available. See you there.